Hopefully everybody can hear the sound on the video, or otherwise they're making arrangements to get the sound up and running. This is the lesson on 712, which is Chapter 7, Section 1, Part 2, out of the Geometry Chapter 7 Study Guide. This one is on areas of triangles. You've probably seen this formula before for triangles, if you're a student of geometry, that the area is 1/2 times the length of the base times the height of the triangle. Now, it's very, very important that you understand what height is. Height is the distance from the very highest point on the triangle straight down to the base. So, sometimes when triangles are sitting on their base in a different way, you might see the height in a different spot. For example, if you have a triangle like this where it's basically sitting on the base, this is the base here, whatever the shelf would be that it's sitting on that level, then the height would be, here's the highest point up from where it's standing from, the base. And if you measure straight down, the height, as you can see in this type of triangle, would measure through the center of the shape. Whereas sometimes you have another type of triangle like this. On this one, the highest point, if it's sitting on the shelf here, the highest point would be here. And if you measure straight down, the height is actually the same as the length of the side. So just be aware that the height can sometimes be in the center of the shape dropping straight down from the tallest point, or it can actually run along the side of a shape dropping down. The base, as I've already alluded to, is whatever the triangle happens to be sitting on, whatever the bottom part is as you're looking at it. So sometimes the base can be in different spots depending on how you're looking at the shape. So for example, if I turn the page this way, all of a sudden this becomes the base and that's the height, right? Or if I turn it back the other way, then this is the base here and that's the height here. You see? Okay. So now we know what base is and what height is. We're just going to do these triangles as they're shown to us. So as I see this one, the base is 16 inches wide. Well, the problem is I don't know what the height is. So what I'm going to do is try to find it. Now, since they put a little right angle corner here, I think they're trying to hint to me that we can use theorems that work with right triangles. And in the previous section, we learned how to do the Pythagorean theorem. That only works with right triangles. When we know 2 out of the 3 side lengths, we can find the third one using the Pythagorean theorem. But of course, only with right triangles. So what I do see here is I see a right triangle on one side and a right triangle on the other, because if this is 90 degrees, this one certainly is too. So what I'm going to do is I'm just going to use that to say, okay, this is an isosceles triangle, and this height would cut that exactly in half. So in the bottom here, from here to the center would be 8, and from the center to the right would be 8, since this is 16 all the way across. And what I see right here, this half, this half is a right triangle. So to find the height shouldn't be too hard. I simply say that leg squared plus leg squared equals hypotenuse squared on this right triangle. Right? Where are the legs? The legs are the 2 sides on the triangle that come together to make the right angle corner. So on this triangle, it looks like it would be these 2 that come together at the right angle. So 8 squared plus 8 squared would be leg squared plus leg squared, and our hypotenuse is 10, so 10 squared. So I can solve this as I did in the previous section. And I find that the height on this triangle is 6. Okay, so now I'm finally ready to find the area of this whole triangle. The area of a triangle is 1/2 times the base of the triangle, which, as you can see, was 16. I labeled it up before. times the height, which we just calculated by using this right triangle relationship here. That's 6. So half of 16 times 6 would be 48. And since these are inches, that would be 48 square inches. This is part of number 10 over here. I'm just going to label that number 10 all the way down the page that way. All right, and then number 11, it's almost exactly the same thing. We have a base going all the way across, length of 48 meters. This is an isosceles triangle, so it's basically made up of 2 right triangles. If we drop our height straight down the center there, you have a right triangle on one side and a right triangle on the other side, like so. And if this is 48 all the way across, that means that each side down here, from here to here would be 24, and from here to here would be 24, like so. Okay, so what I need to find the area of this right triangle, or not the right triangle, excuse me, the area of the entire triangle, the large shape that's shaded in, would be to multiply 1/2 times the base, which is 48, times the height, which we don't know, right? So figuring out the height, we can do it the same way we did with number 10. We recognize we've got a right triangle. We recognize we have 2 out of the 3 side lengths here. We have 1 of the legs and the hypotenuse. So we can find the height here by using leg squared plus leg squared equals hypotenuse squared. So that would be these 2 sides being my legs. They come together at the 90-degree corner. So I have h squared plus 24 squared equals 51 squared. And solving this like I did in the previous section, trying to solve for h. We get 45 for the height of this whole shaded in triangle, and for the height of each right triangle within. So, okay, I've got a base on my whole shape here. I've got the base is 48, I've got the height, which is 45. So if I multiply 1/2 times 48 times 45, or you could take 48 times 45 and just divide it by 2. Either way, you should get 1,080 square meters. Areas are always measured in square units, not regular units. Make sure when you write the square that it's on the letters, not on the number, because if you take the square and you put it over here, you give yourself a wrong answer. It can't be marked correct. All right, we're just going to do one more on this page. It'll be number 27. Here what they'd like you to do is keep your answer in simplest radical form, which means they do not. Simplest radical form means no decimal answers. So you can't get to a point where you have the square root of something and then just plunk that into your calculator and come up with a decimal approximation. No, simplest radical form means that we're going to do this stuff. Like we did in our practice skills, we're going to take the square root and we're going to simplify it if we can. This is simplest radical form. All right? Okay. So number 27, if I want to find the area of this triangle, I'll need to figure out the base and the height. The height is 8, the base we don't know. So we'll use the Pythagorean theorem to find the height. or excuse me, to find the base. So these two sides are the two sides that come together to form the right angle corner. So this would be my legs, this one and this one, these sides, and then obviously that would be my hypotenuse. So if I use leg squared plus leg squared equals hypotenuse squared, I can find x by substituting my two known values and solving for my unknown. Okay, so here I have the square root of 80, and I can simplify that, so I will. The square root of 80 is divisible by the square root of 16. That's a factor. That is a perfect square number, 16. 16 times 5 is 80, so I'll break apart my square root of 80 to root 16 root 5. So x, which is my base length, would be simply written as 4, because the square root of 16 is 4, root 5, because we can't simplify the square root of 5. So if my area of this triangle is 1/2 times the base times the height, I have 1/2 times the base, which is 4 root 5, that's the bottom of my triangle, times the height, which is 8. And so what I'm going to do is I'm going to take 4 times 8, which is 32, and then divide that by 2, which gives me 16. So basically I put together the 1/2 times the 4 times the 8, which gives me 16. Okay? And then the square root of 5 got left out because it can't multiply a radical with whole numbers. So we'll just bring that along and tack it onto our answer. So that is simplified radical form. And it's our final answer, so we'll write it in square inches for our area. And there you go. So obviously we did not have space for 28 and 29. Okay. Over here, I'm going to choose to do number 32. Again, lack of space and time, so okay. So it seems like they've carved out two triangles here, but if they want us to find the area of the entire shape, I'm going to do what I want to do, and that is that I'm going to take the shape that I see, which is right here. I see a rectangle, and then the other shape is a right triangle. See that? If this is 90 degrees, then this is also 90 degrees. So I would need to find the area of the rectangle here, and then find the area of the triangle over here, and then the entire area of the whole thing would simply be, I would need to add the area here plus the area here, and I'd have the area of the entire shaded figure. So the area of the rectangle, I'm just going to sketch it really quickly. Here's my little rectangle. It has a width of 3 and a height of 4. So the area of my rectangle is base times height, or length times width, however you want to do it. However you want to think about it, that is. So I'm going to say the length is 4 and the width is 3. So that gives me an area of this part of the shape to be 12 square inches. The triangle, the base is here and the height is here. So what I see is height is 4, and then how long is this? Well, if this entire thing is 13 and then this section over here is 3, wouldn't this section have to be 10 from here over to there for the whole thing to be 13? Yeah. So that's what I'm going to say, that my base length, that's the bottom part of my triangle, is 10. So the area of my triangle is 1/2 times base times height. So that's going to be 1/2 times the base of 10 inches times the height of 4 inches. So 10 times 4 is 40, half of 40 is 20. So the total area of the entire shape I can simply find by adding the two pieces, the rectangle and the triangle. 20 plus 12 is 32, and this is an area, so it's in square units, square inches. This is very similar to a B-level question that you're going to see on your quiz. And then the last example, these are questions that we're going to do some conversions with. The last two, 33 and 34, are just converting. Well, I should say, not necessarily converting. We are taking previous answers and doing one simple thing to get another answer. It's really the first one, number 32, that takes some thinking and applying of the things we just learned. We're going to apply the Pythagorean theorem, and we're going to apply the area formula for triangles to get the answer to number 32. So it's kind of an involved process because there are kind of phases to the process. We don't just do one thing and automatically have the answer right away. So just keep that in mind. Number 32, I'm going to use some of the space up here. What they want us to do is find the perimeter of this plot of land. But they don't actually give us the lengths. This one is not 4 feet, it's 4x feet. So it's some multiple of 4 in length. So it could be, 16 feet or, 28 feet or 40 feet or 400 feet, or we don't really know. We just know that it's 4x that they're telling us the length is. So it's unknown. And the same thing down here, this side of the land, they're not telling us how many feet it is, but they are telling us that it's some multiple of 7 in length. Okay, so how are we supposed to find the perimeter? Well, did they give us any information to start with? Well, yeah, it says the farmer is planning on cultivating this triangular plot of land as shown in the diagram, this shape here. The plot has an area of 12,600 square feet. So since this is really the only thing they gave us aside from some clues about the lengths of these two sides, somehow we have to put together this area total with the lengths of these two sides. So area, I'm going to start with that. The area of a triangle is 1/2 times base times height, right? Well, this triangle, as we're looking at it, this would be the base down here, right? 7x. And this would be the height right here, 4x. And then they told us the grand total of area is 12,600 square feet. So using this concept of area with triangles, and even though the fact these two side lengths are unknown, as long as our equation only has one unknown in it, one variable, in this case x, we can set up that relationship for area, plug in all the values and terms that we know, and as long as there's only one letter that we don't know, we can solve for that. So if I multiply 7 times 4, that's 28. Half of 28 is 14. And then if I multiply x times x, what do I get? X squared. So 14x squared equals 12,600. So I'm going to divide both sides by 14. And I get x squared to be 900. So if I want to do my last step to solve for x, I got to get rid of the square. Square roots are the opposites of squares, so we'll do that over here. Doing the same thing on both sides gives us an x value of 30. Okay, so does that help us to continue forward in finding the answer we need? Well, essentially, number 32 is asking you to find the perimeter. How long is this side plus that side in length? Well, we've got 2 out of the 3 sides here, and we can find our answer for these 2 now because we know how long x, or how much x is. So the side, this one here, which is 4x in length, would be 4 times 30 feet, which would be 120 feet. And the other side down here is 7 times x, which we now know is 30. So we get, oops, did I write 4? I don't know why I did that. Here we go. 7 times 30, which is 210 feet. So perimeter, all the way around, so far we have 120 feet this way and 210 feet that way. And we just need now to find the distance along the longest side, and we'll be able to find the perimeter, the distance all the way around, by adding those 3 lengths up together. So what I'm going to do is use the fact that this is a right triangle. On a right triangle, when I have 2 side lengths, when I have a leg that's known and the another leg that's known, the Pythagorean theorem can help us find the 3rd missing side. In this case, our side that's unknown is the hypotenuse. So I'm going to continue solving number 32 by saying that I know that leg squared plus leg squared equals hypotenuse squared. So I get 120 squared plus 210 squared equals our 3rd side. I'm just going to call that h squared for hypotenuse. And I should be able to find the length of my 3rd side here. So I have 14,400 plus 44,100 equals h squared. Adding those 2 together, I get 58,500. And so if h squared equals 58,500, I can take the square root on both sides. And here, it's not going to come up with a whole number value. It's going to be approximately 241.9 feet for the 3rd side. So to find the perimeter, that's the length all the way around the whole thing, I'm going to add 120 plus 210 plus 241. So the perimeter is 120 plus 210 plus 241.9. So the perimeter is approximately, because this is an approximated value, all the rest of the numbers we find that uses that would also be approximate. So the perimeter is approximately 571.9 regular feet. That is my final answer for number 32. Question number 33 asks us something very different. It says that it defines an acre, an amount of area is an acre, if it's 43,560 square feet. Remember, square feet is not regular feet. It's a measure of surface amount. So if our square feet up here for this land is 12,600, do we have a whole acre? No. 12,600 square feet is a lot less than 43,560 square feet, right? So we have some amount smaller than 1 whole acre, right? Maybe half an acre. So how do we figure out how many acres we have? Well, if we have 12,600 square feet and we divide that by 43,560 square feet. This is the part that we have out of a total acre, which would be this, right? So we'll be able to figure out what proportion of an acre we have if we take our amount and divide it by 1 whole acre. So we get 0.289 and so on. They want us to round this off to the nearest 2 decimal places, so that would be 0.29 acres. And that makes sense. We don't have a whole acre. We have something less than that. In fact, it's less than half. We have 29% of an acre, basically. And then finally, number 34, we're going back to number 32. 32 said that we have a perimeter all the way around of 571.9 feet, right? Number 34 says, okay, if every 12 feet we want to put a post, wouldn't there be 10 posts here on this side that's 120, right? So every 12 feet, 1, 2, 3, 4, 5, there'd be 10. So how many posts would we have if we went all the way around the outside? Well, all we really have to do is take our total perimeter, which is 571.9 feet, and divide that by 12 feet, because every 12 feet we would put 1 post. And this gets us, when we divide it, 47.658. So that means we don't have enough space to put a 48th post, but we could certainly put in 47 posts that are 12 feet apart around the outside of this land.